Hello friends, in this video lecture I want to explain the adder and subtractor using the operational amplifier. In the previous lecture we already studied inverting and non-inverting amplifier using the op-amp. Now the presentation sequence of this lecture is: first I will give the introduction about the op-amp, then second I will give the adder, what is the adder and how it can be built using the operational amplifier. Then next is the subtractor. Then I will take some problem based on the adder and subtractor, and finally go for the what is the multiple choice question. Now let us see what is the operational amplifier. So operational amplifier basically the differential input and single-ended output amplifier. So it performs the various mathematical operations such as addition, subtraction, integration, differentiation. That's why it is called as the operational amplifier. So one of the most reason for popularity of the op-amp is the that is the versatility. We can do almost everything with the op-amp here, and for designing the circuit using the op-amp here, it doesn't require thorough knowledge of the op-amp here, and this makes the design process easy using the operational amplifier. Then we consider the summing amplifier first, that we call adder. So this is the summing amplifier or adder using the operational amplifier, and it's basically the inverting summing amplifier because they are applying the input to the inverting. The inputs voltages which we want to sum, that is V1, V2 and V3, they are applied to the inverting terminal to the respective resistor R1, R2 and R3 here. Then there is a feedback resistor RF is used connected between the output and the inverting input terminal of the operational amplifier. Non-inverting terminal is grounded. Then we analyze, we find out what is the output voltage of the summing amplifier. So the op-amp is designed to get the summing amplifier adder. So due to the input voltage V1, V2 and V3 which are applied here, so these V1, V2 and V3 these are applied to the input voltages here, to the inverting terminal here. So because of this input voltage V1, V2 and V3 which are applied to the R1 and R2, so therefore the current I1, I2 and I3 that goes through this respective resistors here. And then all the resistors they will get sum up at this point which is called a virtual ground here. This is also called a summing point here. All the currents get summed here. As the input impedance of the op-amp is infinite here, practically it's very high, so therefore no current flows through this input terminal here. So whatever the sum of current that flows to the feedback current here, and thus therefore the current which is flowing through the feedback is nothing but the sum of these currents here, I1, I2 and I3 here. Then so therefore feedback current, that is the IF, there is nothing but I1 plus I2 plus I3. Then we know what is the value of I1 and I2. So as the current goes through the feedback resistor RF, the potential is developed across the feedback and which appears as the output, which is nothing but the output voltage. And it's given by what? V0 is equal to minus IF into the RF. So this what is IF? IF is nothing but the I1 plus I2 plus I3. We just multiply with RF, we get the output voltage. Now we can substitute the value of I1 because of this summing point which is the at virtual ground. So the current I1 because of V1 is V1 upon R1, I2 is V2 upon R2, I3 is V3 upon I3. So we substitute this value in this expression here, we can get the V0 is equal to minus of V1 upon R1 plus V2 upon R3 plus V3 upon R3 into the RF. And then if you have this resistor R1, R2 and R3, if they are same as R, if the all resistors are equal, then we can get this output is nothing but minus RF upon R into the V1 plus V2 plus V3, where this minus RF upon R is the constant and which is nothing but the gain of this summing amplifier here. So as it is constant here, therefore the output voltage is proportional to the sum of V1 plus V2 and V3 here, and this negative sign indicate that it's a output voltage is negative here. So therefore thus the output voltage of this summing amplifier is proportional to the negative sum of the input voltages. Now we consider the problem based on this non-inverting summing amplifier here. So let us consider the first problem, that is calculate the output voltages for the operational amplifier which is in an inverting mode here with the following sets of inputs and resistors here. So here we can have the RF is 2 kilo, R1 is 1, this RT 1.5, RF is that is 2 kilo, and we are applying the input voltages here, and we have to find out what should be the output voltage. As it is a summing amplifier here, you know that. So therefore the output of this summing amplifier adder is given by this formula here. We just substitute the value of this respective voltages and the currents here. So we can get this voltage is equal to minus 3.13 volts here. So this negative sign indicate that. So what are the input which is applied here? It's get inverted and it appears at the output here. Now consider the second problem here. Again in this case we have to find out the output voltage. So this circuit is given here. It's having the inputs 2 milliwatt, 5 milliwatt applied to 1 kilo and 2 kilo. Feedback resistance RF is 10 kilo, and so that we have to find out what is the output voltage. So therefore it has two inputs here. So therefore output is given by this formula here. We substitute the value of this V1, V2 and R1, R2 and RF. So we can get the output voltage is equal to minus 45 millivolts. You can see the third problem here. In case we have to calculate the output voltage for the summing amplifier, which is shown in the figure here. So it has three inputs V1, V2 and V3, that is 1 volt, minus 2 volt and 0.5 volt. So therefore the output is here V0 is equal to minus RF into the V1 upon R1 plus V2 upon R2 plus V3 upon R2. Just substitute the value of V1, V2 and V3 respect to R1, R2 and RF here. So we can get the output voltage is nothing but what, that is equal to 2.5 volts here. Then again this is the summing amplifier which are having the four inputs here, VA, VB, VC and VD here. So that we have to sum it here. So therefore output voltage is nothing, since all the resistors are same here, so therefore the output voltage is nothing but the sum of all these input voltages here, that is VA, VB, VC and VD here. So therefore we can get the output voltage is equal to 4 volt in this case. Then we consider another circuit which is called a subtractor. This is another application of the op-amp known as a subtractor, or it is also difference amplifier here. So in this subtractor or difference amplifier, it provides the output voltage which is proportional to the what subtraction of the input voltage, that gives the difference in the output voltage, input voltages. In this case here V1 and V2, these are the voltage applied to the, V1 is applied to the inverting, non-inverting, V2 is applied to the non-inverting mode. And there is a feedback resistor here, we call it R2 or RF here, connected between the inverting terminal and the connected between the inverting terminal and the feedback resistor here. And this non-inverting terminal is grounded through the resistor R2. Now we can analyze this subtractor as, so this is the subtractor circuit here. Here we apply the V1 and V2 as the inverting and non-inverting input. Since we are applying the concept of the virtual ground here, since the potential at these 2 points will remain same here, that is inverting is equal to non-inverting here. So the non-inverting input is obtained by this voltage divider arrangement formed by R1 and R2. So this is given by V inverting is equal to R2 upon R1 plus R2 into the V2. The voltage at the inverting terminal can be calculated by the superposition theorem by using this thing here. And if you substitute the respective values in this, and if you rearrange the equation here, then we can get V0 is equal to R2 upon R1 into V2 minus V1. Say R2 upon R1 is nothing, if we make it same here, that is R here, so we can get the V0 is equal to R2 upon V2 minus V1. So this equation shows that the output voltage is proportional to the difference in the input voltage, or it is the subtraction of the input voltage here. And the gain is given by AF is equal to V out divided by this difference, that is nothing but the R2 upon R1. And if R2 is equal to R1 is equal to R, then it is called as gain is 1 for this. So thus the difference amplifier rejects any signal common to the both inputs here. It means that if the polarity and the magnitude of both the input signals are same, the output must be 0, as this equation shows that if both the inputs are same, output is 0. We consider some problems based on this. So this is a subtractor circuit having the R1 and R2 is given by 1 kilo and 2 kilo. V1 is 2 volt and V2 is equal to 5 volt, then the output voltage is given by V0 is equal to R2 upon R1 into the V2 minus V1. If you substitute the values of voltage and resistance here, we can get the output voltage is equal to 6 volt. Then this second problem here, we consider again we have the V1 and V2. These are the two input voltages here, and the respective resistors have, all resistors have 10 kilo ohms here. So V1 is 2 volt and V2 is minus 2 volt here. So therefore the output voltage of this subtractor circuit is equal to V0 is equal to R2 upon R1 into the V2 minus V1. So since R1 and R2 are same here, so therefore this voltage comes out minus 2 is equal to minus 4 volt. Now we can say a very simple MCQs test based on this topic here, that is adder and subtractor. So the first question is that in which amplifier the output voltage is equal to the negative sum of the all inputs voltages. So this it is possible in case of what, the summing amplifier here. So therefore the answer is summing amplifier. Then the second question is inverting amplifier with a gain 1 with a difference voltage of different voltages of 1.2, 3.2 and 4.2. So here we can say the gain is 1 and the input voltage are 1, 3.2 and 4.2, which are applied to the inverting amplifier. In order to find out the output voltage is equal to. So here the answer is just gain is 1 here of this inverting summing amplifier here. Therefore it's just the addition of this 3 here. So therefore the answer is minus 8.6. Then we have to find out we have to determine the expression for the output voltage for the inverting summing amplifier. Consists of the 4 internal resistors here, and we consider here all the internal resistors have equal value here. So therefore these options are given here. Out of these, the option is, the first option is correct, which is nothing but minus Rf upon R, so gain here, and the addition of all these voltages VA plus VB plus VC plus VD, all the voltages are. Then fourth one is with 0 volt on the both the inputs, and op-amp ideally should have the output voltage. It's a very simple case here. What should be the output is 0 voltage finally. And the last one is here, if the inverting and non-inverting inputs of the op-amps are represented by V1 and V2 respectively, then the output voltage depends upon what? Naturally it depends upon the difference in the input voltage here, that is non-inverting minus inverting, that is V2 minus V1. With this, thank you very much.